us for the amazing event. We call it State of AI. It's a tradition now already that we host together during the summer school this event with Clemens from AI Austria. It's a pleasure that you're here. Thanks for your support.
Thanks for the kind words.
As I've already mentioned, State of AI is part of the ICT Summer School. For those who are not familiar with it, what is it? It's a 7-day deep tech bootcamp in the middle of the amazing Alps, also with amazing weather, maybe a bit too warm. We Austrians are not used to it, but never mind. We have got 30 amazing entrepreneurs here for a week. They work really, really intensively on the projects. Since last Friday, we've kicked off, and now it goes until Thursday. I heard from them it's really, really intense, but I also hope that they can learn a lot and take away from it, so they can develop their projects and themselves further. We have got 30, as I've mentioned, entrepreneurs here this year from 15 different nationalities, and they work with over 100 mentors, experts, and keynote speakers over those 7 days. I'll hand it to you over.
Great, thank you very much. Yeah, as Victoria mentioned, I'm Clemens from AI Austria. I wouldn't even say that it's a tradition, because now is the 7th time we have State of AI. It's actually an institution. Maybe before we start, who of you knows ChatGPT? Oh, more than 2 people. Who of you knows AI Austria? Not that many. So, okay, let me tell you a couple of words about AI Austria. I mean, we are a non-profit organization. We were actually established in 2018, which is 5 years ago, but the original idea was born here in Watten 6 years ago to the day on the stage here. We are 100% independent. We consider ourselves like a grassroots movement. You have very similar organizations, let's say for the people of you that are not from Austria. We are very closely related to, let's say, the German Bundesverband KI or Hub France IA, or to the, where's our Dutch participant, to the Dutch AI Coalition. So you have similar organizations all across Europe. Yeah, if you want to know any further information, please always head to the webpage and so on. I would not bore you with this one. Yes, as mentioned before, it's always very great to come back here, because it's really quite a coincidence what you see here. Yeah, I mean, this is of course Hermann, looking young as always. This one was me without gray hair, so this was 6 years ago, and when we had the first discussion, it was interesting, because back then the AI hype, or let's say the discussion around AI, was happening on a totally different level. Back then you would perhaps talk about self-driving cars or cat videos on the internet from Andrew Ng, for example. This is how this whole boom started. And since then, the discussion has evolved. It also became far more related to let's say, policy making, European AI Act. We will touch upon that later in the intro or in the panel today. And over the years, we also developed in that way the format for the event as such. How to say? Yeah, where to find us and so on. This is insofar interesting, as let's say, we established many local chapters, and the head of AI Tirol is also standing directly in front of me. Those online unfortunately can't see him, but yeah, he's the one waving. So there are many local chapters. We started their own event series and so on, yada yada yada. But yeah, if you want to have any further information, I won't bore you further with a non-profit advertisement. As Victoria mentioned before, the ICT and the State of AI event is also supported by the FFG, the Austrian Research Promotion Agency, and who would be better qualified to talk about this than Mr. Jan Arpe, the man with the hat and soon with a microphone. So please join me on the stage.
Turn it on. Thank you, Clemens. Well, yeah, welcome also on behalf of FFG, the Austrian Research Promotion Agency, and its Global Incubator Network Austria. It's a real pleasure to be here, actually for 2 reasons at least. One is very personal. Until 15 years ago, I actually did academic research in northern Germany, in Lübeck, and in Berkeley, that's in California, at the intersection of computational complexity theory. I'm not sure if anyone knows in this room what that is, just from your basic studies probably, computer science 101 and then never did it again. The intersection of this and machine learning, I guess you've all heard about this term by now, of course. The other reason is because I'm very proud to be able to support this as a representative of FFG. And you know, the vast majority of projects funded by FFG, of course, involves some type of AI, right, by now, no matter in which vertical. Be it the employment of tools or really the development of novel AI tools. And as a public agency, we have to make sure that the way we spend the money and the way it's spent then by the companies, that this is done in an ethically sound manner, right? And that ideally this contributes not just to the well-being of the fundees, but to the well-being of society at large, or at least doesn't harm it or, you know, endanger it. And guess what? I mean, that's a problem for many innovation agencies around the world. There are lots of discussions, and it takes a lot of time. And given the unprecedented speed of technological development in the past, like 1 year, 2 years, specifically, I'm not so sure if we're going to really win that race. But what we can do as a public agency, we can support events like this one. And I think the discourse on, public discourse on AI, the discussions, the conversations on those developments, on the benefits on the one hand, but also on the challenges, are more important than ever before. And so we're really proud to support this together with great partners like AI Austria. And we're also very grateful to ICT for organizing this event series, actually in the past year and also tonight. So I wish us all a very inspiring and thought-provoking and also entertaining evening. Thank you.
Thank you very much. It was actually interesting to learn about your background, because if we would have known 5 minutes earlier, there would be an additional chair here. You perfectly fit the bill.
I'm unprepared. Next year, maybe. Okay, thanks.
So what awaits you now? We just finished with the welcome part. We will start with 2 keynotes. The first one on AI productivity lessons from GitHub Copilot by Mr. Huch de Moor from the Netherlands, living in Malta, before in San Francisco. So you know the usual CV. Followed by Steve Barlow from GraphCore. Yeah, the people online can't see, but hello, Steve. Yeah, and after the keynotes are finished, we will switch to the panel to discuss the topic of today, of like expectations and realized benefits. So without further ado, please, with me, welcome on the stage, Uche. And fingers crossed the switch works. No, not yet. Yeah, that's it. Perfect. Could you also check if you're in the check if you're in the StreamYard? Yeah, perfect. Good.
Okay, thanks very much for this opportunity to share with you some of the lessons about how AI can boost productivity that I've learned while leading the creation of GitHub Copilot. I should say at the outset, I no longer work for GitHub or Microsoft, so what I'm going to tell you is purely my personal opinions, personal reflections. In order to get all of us on the same page, I want to go and show you a very brief little demo of how you can use GitHub Copilot. If you're not a coder, do not be worried. What you will actually see is that I write some stuff in English, and the AI will write the incomprehensible, boring code. Throughout, I want you to carefully look at how I use the keyboard. Every time I hit a key, it will light up in bold lettering on the screen, and so you can see exactly what it is that I write, and everything else is written by the AI. The app we're going to write is a simple data crunching exercise. We're going to ask the user for a list of books, we're going to look up each of those books on the Goodreads website, scrape the average rating of each book, and then show the results in a bar chart. Okay, so in order to get started, let's write a function that gets the titles. We ask the user for a list of books, 1 per line. And you can stop when the user enters a black line. Whenever you see a piece of text in gray, that's actually a suggestion from Copilot. It's a suggestion from the AI, and I accept it by hitting the tab key. And return a list of the books entered. Yep, that's what I want. And then it actually wrote the entire function implementation. So what happened here is that I, the human being, typed in the piece that's highlighted here, and the complete implementation was then taken care of by the AI. Of course, it's a simple example, so let's see how it does when we do a little bit more involved stuff. So as I said, we want to get the list of books, and then we want to talk to the Goodreads website in order to get the data. Now, in order to talk programmatically to the Goodreads website, you do need an API key. So let me go and get that. Small technicality. And now we want to do the scraping. With a list of titles in hand. And what does it mean to do the scraping? We get the average rating of each book from Goodreads. We want to return a list of floats, which are the ratings. And if a book is not found, use 0.0 as its average rating. So now, the AI actually wrote quite a bit of code. It's code that goes and fetches the data from Goodreads, it parses the data that it gets back, and then it puts the ratings in a list, which is returned as the result. So personally, this is not something that I would have been able to write without going and looking up how I use that, the beautiful soup library and all that kind of all that kind of thing. Okay, so clearly what I want to do next is to plot the results. Sometimes the AI is uncannily in line with my thoughts. It actually already suggests that it plots the ratings, and then it implements the whole function. I didn't need to do anything at all. So now, we want to put it all together. Get the titles, scrape Goodreads, and plot the ratings. So let's try that out. Ulysses, quite a boring book. Wuthering Heights, a little bit better. Norwegian Boot, one of my favorite books by Haruki Murakami. Watching a demo like this is like going to races, right? You're actually waiting for the crash. You didn't get a crash. It actually did give us the bar chart that we wanted, but it's not so nice that the titles are not quite visible. Of course, I could resize the window and then you can see the titles, but instead, let's ask the AI how to fix this problem. So here I entered a chat window, and now I can just have a ChatGPT-like conversation about the program that I'm writing. How do I ensure that the plot fits in the displayed figure always? Okay, it suggests that we use this tight layout function, which I haven't used before, but let's try that. Just stick it in the place where it suggests that we do that. And this time I'll just write enter Wuthering Heights. And sure enough, as you can see, we now get the full title without it running out of the displayed area. So, what did I actually show you here? I typed 7 lines of English text. I just described what I want the computer to do. And then the 50 lines of Python code were completely written by the AI. And so programming becomes a very different activity. It's much more about thinking hard about what you want the computer to do, and still you have to be very precise in expressing that. But you can express it in English, and then the translation to code is done by the AI. Cool demo. I hope you agree it's a cool demo. Unfortunately, lately I've seen lots and lots of cool demos using AI, and they work great on one example. And so it's a legitimate question to ask, does this actually boost the productivity of developers who use it every day? As a first answer, we can look at a very technical metric. Do they actually accept the suggestions? And yes, they do. Over a year ago, it was 27% of the suggestions they accepted, then it was 30%, and in December, it was 35%. It's now almost 40%. So this goes up, and people do accept these suggestions. But that's not a productivity boost. Perhaps they think a very long time before they accept a suggestion, or perhaps they spend a very long time debugging the suggestions. So in order to get a better handle on whether it's really a productivity improvement, my former colleague Rini did a very careful survey of 2,000 users of Copilot. Of those 2,000, about 60% are professional developers who use it day in, day out. And the other 40% are amateurs and also people who sometimes write some code, but it's not their main job. 88% of these people feel they are more productive when they're using Copilot. And perhaps even more exciting, they like it better. They feel less frustrated when coding, they feel more fulfilled with their job, they can focus on more satisfying work. And remember, that's what we saw in the demo. It was all about what you want the computer to do. And then the boring stuff, how you fetch data from a website and how you parse it and all that, taken care of by the AI. They also feel that they actually work faster. 88% of people think that they complete a task faster with Copilot. And in particular, that is true of repetitive tasks. And repetitive tasks like the stuff that I showed you, I mean, come on, there was no really interesting code there. It's bread and butter, but it slows you down if you have to go on Stack Overflow and look up how you exactly should do this thing, or you have to read the documentation of the API. And so they feel that they're more in the flow, that really focused state where you do your best creative work. That's because they spend less time searching and they don't have to waste their mental effort on repetitive tasks. So this is better than the first technical metric of productivity we looked at, but it's still perception. We asked people and they feel better, and of course, since they're paying customers, we like that. But what about doing a proper A/B experiment? We asked 95 developers to all do exactly the same thing, namely implement a web server in JavaScript. About half of them used Copilot and about the other half did not. about the same number completed the task. But look at the time that it took. With Copilot, they took 1 hour, 11 minutes. And without Copilot, they took 2 hours, 41 minutes. That's a 55% saving in the amount of time they spent coding. This is a big deal. So are there some lessons that we can abstract from this that could be useful to other products that are also infused with modern AI? So the first thing that I've learned is that you should really build for future models and not for today's. All the way back in the fall of 2020, when we were starting to build Copilot, what we envisaged was a ChatGPT-like bot where you could ask questions. And that feature that I just demoed to you, where I asked it, how do I make sure that the plot always fits the figure, it's only being released right now. So this is, if something works almost with the current state of AI, you better assume that it does and already built the UX and everything with that anticipation. Nevertheless, these models will always continue to make mistakes. And it's very important for UX to be tolerant of them. In Copilot, we succeeded with this by showing these suggestions in gray text. And they just go away if you keep typing. If you ignore them, the cost of saying that's wrong, I don't want it, is almost zero. It was not always like that. At the beginning, we thought it would be nice to have a feature where you could explicitly ask for the suggestions, and you hit the key combination and you get a list of suggestions of 3 or 5 or even 10 suggestions. But then when we tried it out with users, nobody wanted it. And nobody wanted it because, first of all, they had to interrupt their normal flow to explicitly ask, give me a suggestion, and then they also needed to read through all these things, and then they were very frustrated when none of them were right. And so you have to make sure that the cost of mistakes by the AI is very low. I'm a technologist, and like every technologist, I believe that the most powerful, the latest, the very best technology is what the users want. This turned out not to be the case. The model behind Copilot is not GPT-3. It is not even the special code version of GPT-3 called Codex. It's a much smaller model, and it's a much smaller model because we needed to balance the speed with the power. One time we rolled out a very powerful model to 10% of the users, and we got lots of complaints. I mean, the metrics for these users became very bad. And the reason was that they typed faster than the model could give it suggestions, and so they didn't see any suggestions, and they thought something was broken. So you really need to let the users choose which model is best and not be seduced by the latest technology. And finally, a word about AI risks. Of course, throughout the whole project, we were aware of all the trouble that comes with using generative AI. There's license and copyright questions. There's security questions. Perhaps it's going to inject security flaws into your system. There's problems with bias, even in coding, that can be quite offensive. However, the biggest risk that I kept reminding my team about is user indifference. It's very easy to make something that is safe, but actually doesn't boost productivity. And to give you one concrete example, when we rolled out the first version, AI researchers in safety came back to us and said, why don't you color all the text? You should color all the suggestions that were made by Copilot, because then people can see that this is AI-generated code, and they have to be extra careful. They have to read it very well before they change it back to the normal color. But this is that throws away the productivity gain. As I've already said, the unobtrusive nature is very important. So AI risks are important, but the biggest risk to your own product is that people won't use it. So that's all I wanted to say. I would like to thank my former team at GitHub Next. GitHub Copilot was created by a team of just 10 people at the time it was released. I mean, it started with me, then I hired 2 engineers. Over time, we got 7 more engineers, but there were only 10 people who got it to 1 million users. So you don't need a big team in order to have a big impact. Of course, we were very much helped by our collaborators at OpenAI, very grateful for them listening to all our requests, all our feedback on the models. And once it did become very successful, the Microsoft Azure OpenAI service made it possible to scale it enormously. So thanks very much. Looking forward to the discussion.
Thanks a lot. Yeah, now, see, I can even give you a laptop back. So you deserve it. Thank you. Yeah, see you later on the panel discussion soon. Now just a brief moment, because we have to connect the laptop again, because the second presentation will happen from this computer. So, does it work? 1, 2, 3? Not? 4, 5, 6? 7? Yes? Oh, yeah, see, 7 is the magical number. Good. Now, just PowerPoint needs to play along. Yeah, perfect. Now with me on the stage, the next gentleman. We are now leaving the software side and walking to the semiconductor side. Yeah, the microphone is delivered as we speak. Yeah, Steve.
7.
Yeah, this is how you start a cargo cult. No, this was not my intention. But yeah, you will tell us now a little bit about, let's say, GraphCore's approach, and let's say the benefits and role of custom silicon in AI. And we are, as with the previous keynote, save your questions for later for the panel discussion, because we will directly continue afterwards. So the stage is yours. And for the presenting, you just use here the left and right. Perfect.
Okay, so I've done quite a few different things in my career. I guess I'd describe myself as a mixture between an entrepreneur and an engineer. I worked for a long time for a technology consultancy in Cambridge, and then I have variously founded 2 startups, both of which had successful exits. And then I got interested in AI. And so for the last 2 years, I've been working for GraphCore, not really in a sort of senior leadership position, but as a member of the engineering team, working on large models and how to make large models work well on GraphCore's hardware. The theme of the discussion this evening was around AI going from hype to really working. And so I thought I'd start by talking about some different applications of AI. And I think from those you can see that there are a lot of things that are really working. The first example on the left of my slide is using AI for breast cancer screening. And there was a study published recently that showed that it is as good as 2 radiologists. The usual way in which apparently you do this diagnosis is you have 2 separate evaluations by 2 different radiologists, and the AI was giving results that were as good as that. So where you've got this quite constrained problem, and you can get a good amount of data, an AI can do really well. And so this is an application, this is a super application, it works really well. The second example I've got here is drug discovery. So this is AlphaFold, the protein folding analysis tool from DeepMind. And again, this is something that works really well. Both of these examples, they're not, I think, something where you would say, okay, we're just going to hand the job completely over to the AI and it can do it completely independently. What you're doing is you're using the AI to help you. It augments the human processes with greater productivity or better accuracy or whatever. Some other examples that work really well. So translation, Google Translate or DeepL. It's magic. Speech recognition or text-to-speech. So Whisper, another OpenAI model, is really state-of-the-art in terms of speech recognition and has moved the science really a long way further. It's in some cases considered better than human recognition. And then there's a couple of perhaps less well-known ones. A very nice application is being able to search your company data. And not doing that by keywords in the kind of form of a Google search maybe, but by doing it by semantics. So you can take loads of data and you can put it through a language model, and for each segment of text, you can get a set of vectors that describe the semantics of what that paragraph is talking about. And then you can do searching by matching your query with all of these vectors. And that turns out to be a very satisfying way of doing high-quality searching. You can then do another step, which is to take the pieces of data from your search that had high scores and put them into a language model and ask the language model to actually answer the question using this data. And that also works quite well because you get some answers, but you also get some references back to the source so you can check whether it's hallucinating or not. A couple of things that have caught the public imagination are text-to-image models. So here we have an example. I asked Stable Diffusion to give me an image for a cat sat on a hedgehog. And yeah, we get an image of a cat sat on a hedgehog. I think it shows also that it doesn't really understand because the cat looks quite comfortable. And also interestingly, the way these text-to-image models work is they have a text, large language model, that is feeding conditioning information into a much smaller model that is actually producing the image. So all the thinking, if you like, goes on in the text model, and then the image model is just making things out of the bits. Of course, the next example, ChatGPT, can help you with writer's block, it can create poetry, it can do all sorts of things, but you probably wouldn't trust it on its own. Again, this idea of using AI to help rather than to completely replace. There's some more. I think I'd like to make a particular plug for smaller models. You've got these huge models like ChatGPT, but actually you can do an awful lot of things with much smaller models. And they can be much more reliable and trusted to do what you expect. So sentiment analysis, is this text positive or negative? Classification, which of these 10 things is this paragraph talking about? You can use those as the basis of some sort of automated response system. You can use it for automatic scanning of market data, all sorts of things. So these smaller models are actually still, I think, the backbone of what most people are doing, even though the talk is all of ChatGPT. So applications do work. The next thing I thought was interesting to talk about is where's all this going? And in particular, if language models, large language models, are the vehicle for capturing and using reasoning as well as world knowledge to answer questions and provide an AI service. How are these large language models going to develop? So there was a good piece of research by Google Brain, that concluded that as you make these models bigger, they're able to do more things. And so you increase the number of parameters, you increase the amount of data you use to train it, and it develops abilities to do harder things. We've still got a long way to go before we create anything that's the size of a human brain. So this model that Google produced, Palm, it's about 500 billion parameters. If you think of each parameter being a bit like the weight in a synapse of a brain, the brain has about 100 trillion synapses. So we're at least 2 orders of magnitude smaller than a brain, possibly 3 orders of magnitude. So can we just keep scaling up? And I think the answer to that is a fairly definitive no, because the amount of compute that you've got to do to train a model like that is proportional to the square of the number of parameters. So that 2 or 3 orders of magnitude now becomes 4 or 6 orders of magnitude. And so that's not really feasible. But actually, it's also not how the brain works. You don't use every single synapse in your brain for every question that you are thinking about. You've got to have some selectivity where you're using just some parts of your network, if you like, that are specialized to that particular problem that you're trying to solve. And that selectivity is possibly one of the ways forward. So people variously call that using mixtures of experts, or possibly a bit less clever is ensembling. That's where you take a number of different models. It's like you have a committee answering your question. And that is how GPT-4 is rumored to work from the releases onto the internet. We don't actually know exactly how it works, but that's the suggestion, that it's an ensemble of 8 models. OpenAI had been fairly good at publishing information about what they'd been doing up until GPT-4, but with GPT-4 they published a technical report that gave quite a lot of performance information, but didn't say anything about what they'd done and how they'd done it. And since they've gone dark, all of the other big research labs have gone dark as well. So we're actually getting to a place where there's rather too much secrecy now. You can't see what's going on. There's a nice little parody here that suggests, well, you know, the GPT-4 technical report, what did they actually say? What they said was, we used Python. And that was all the information that you got. So I'd say that's a problem, that there isn't the openness of research information. And it's hard for universities to do this sort of research because you need large amounts of compute. There's another dynamic. How does ChatGPT get to be so helpful? The answer is it's been trained using this thing called RLHF, which is reinforcement learning through human feedback. Effectively, you have human raters that look at its answers, and it gets trained to produce answers that are more helpful, more harmless, more useful to human beings. And that, unfortunately, is a behavior that has a circle to it. If OpenAI are serving this model. They get the most feedback. They can make the most improvements. Their model gets better the fastest. It's a winner-takes-all behavior, and I think that's another risk. We've got at the moment a very small number of companies that are operating large language models. We don't want that small number to become entrenched through a positive feedback cycle. Finally, what's going to happen with these large language models? At the moment, they're very expensive to serve, but that is going to improve substantially in the next few years. Both improvements in architecture of the model, detailed improvements, assistant models, grouped query attention, quantization, knowledge lookup, etc. But also in the implementation, how you do a thing called attention, which is one of the components of these large model layers, how you get higher memory bandwidth, and so forth. So it's interesting times, and it's particularly interesting times if you're working in the area of making hardware for implementing these models. There's lots of kind of, in the press, lots of talk of doom, how everybody's going to lose their jobs, or AI is going to take over the world, and so on. I think this is much more realistic as to what's likely to happen. It goes back to what I was saying on the first slide. You can use AI to help you. It doesn't replace you, it helps you. And so you're going to get replaced if you're not using it. So use it. I mean, there are some real dangers, clearly. The secrecy, I think, is a danger. There are information dangers, like with the internet, but maybe more so because these models are more concentrated. There's also a question, what kind of applications can you create with AI? As an entrepreneur, what can you do to create interesting businesses? You can, of course, go front and center. I've got this new AI technique. Here it is. Everybody needs it. It's like Google search. It suddenly replaces everything. But there's not going to be very many of those. I think much more likely is AI applying to backroom processes. It makes you more efficient. It allows your business to do this thing more efficiently than it used to do it. It lowers the cost of doing something else. And that perhaps means it isn't startups that are going to do this. It's going to be established companies that can benefit from applying AI to make their processes more efficient. And if, as an entrepreneur, everybody's got access just to the same few large models, the same APIs from OpenAI or Anthropic or, etc., how are you going to create something that's differentiated? So I think there's quite a lot of challenges for, although AI is a huge disruptor, there's a lot of challenges for how you can actually turn it into making an interesting business. Okay, so that's kind of part one of what I wanted to talk about, sort of general themes related to AI. Part two, I was asked to talk a little bit about GraphCore and why it's important to have independent semiconductor solutions. Why does AI need anything different at all? Why can't we just use a standard CPU to run these models? The answer is that they need absolutely huge numbers of floating point calculations, big matrix multipliers, in order to have the number of parameters and the complexity of behavior that allows you to make a large model. And that number of calculations is 2 or 3 orders of magnitude more than you might get with a CPU. So you really need something that can do all these calculations in parallel. Lots of people use NVIDIA GPUs to run both training and inference for these large models. And the GPU is great because it can take the same basic operation and it can apply it over a huge number of a huge number of elements and give results. But it is limited because it can only do the same thing. So we can't have a CPU because a CPU doesn't do enough compute. A GPU is okay, but it's doing the same thing for everything. This is why the IPU was created. It's a different technology architecture. So in computer science terms, it's called a MIMD processor. We've got many thousand individual processors on one silicon die, each with local memory, each running their own separate program that operate together to implement the calculation, the large matrix multiply, or whatever it is that you wish to do. And there's a complicated mechanism that allows all of these individual processors, tiles, to communicate with each other. This is what one of GraphCore's pieces of hardware looks like. So beneath each of these heat sinks, there is a IPU, GraphCore's processor. This is just taking all the heat away. So it's a 1U chassis with 4 of these IPUs. And we can run all of these large language models. Here's some examples. You can try these out on Paperspace, which is a cloud environment. We've also got some of the image generation models that you can try. So, is it all just about the hardware? No, not at all. I would say within GraphCore, there is probably about, well, certainly more than half of the engineers are working on software rather than hardware. The tools that allow you to take a graph that describes a lot of matrix multipliers and other operations and maps it down to something sensible being done by all of these individual little processors to work together to create the results. That's a pretty hard problem, and there's quite a lot of software involved in doing that. But also, you've got to work with the whole existing ecosystem. Because if it's hard to use an IPU compared with a GPU, people are not going to bother. It's got to fit in the same box as far as the user is concerned. So software is as big a problem as hardware for this. Final slide. I just wanted to show you an example of a large language model running on IPU. This is a chatbot called Luminous by the German company Aleph Alpha. And the interesting thing about it is we have taken the model and sparsified it. So if you imagine you could have connections between every different neuron in a brain, you don't need all of them. So you can take out the ones that don't really add to the result very much and end up with a much simpler calculation. And that simpler calculation can be done efficiently on a device like an IPU, but actually couldn't be done efficiently on a device like a GPU because the GPU needs this regular pattern. So this is an example that's kind of really playing to the GraphCore IPU strengths. Why do we need an independent solution? Just look at the market share of NVIDIA. It's not good for anybody that they have 80+% of the market. It's not good for innovation, it's not good for competitiveness, and it's also not good for any kind of European sovereignty, because all of these parts are developed in America, manufactured in Taiwan. We need to have the ability not just to build semiconductors here, but also to design them here and design complicated things like the IPU. Okay, thank you.
Thank you. Well, I think you could already take your seat. Okay. So, I mean here on the stage. Yeah, excellent. Yeah, while we reconstruct the stage, which should be finished in 10 seconds, welcome with me on the stage Hermann Hauser. Yeah, I mean, introducing Hermann on his own summer school that he started always feels a little bit awkward for the 0 people of you that don't know Hermann Hauser. Co-founder of Acorn, later spun out ARM, vice president of the European Innovation Council, founder of Amadeus Capital, being in venture capital and deep tech since many, many years, and yeah, most importantly, the founder of the IICT. So next on the stage with me, we have Monika Köppel-Turina. She's the director. Yeah, Monika is, let's say, coming from the opposite side. Also, yeah, not only geographically, but also from the scientific discipline. She's an economist by training. She's one of the leading economists in Austria. And she, let's say, starting from last year, we have a collaboration together to assess the economic impact of AI on let's say, on the labor market, on the diverse, let's say, economic fields. And we will also have a conference later this year together, but Monika will tell you more about this one. And last but not least, the Mr. Live Demo, Uche, for the last seat. Yeah, maybe one final reminder as far as questions are concerned. Please keep them in mind. We will have a Q&A session once we wrapped up with with our discussion. So good. So let's start. Yeah, let's say the topic of our state of AI part 7 this year is from inflated expectations to actually realized benefits. And I would say that the boom, we also heard this in Steve's, let's say, keynote before, started around 10 years ago. And when you had this image with radiology, I remember, I think it was Kai Fu Lee in his book AI Superpowers that mentioned that the job of the radiologist will be in the future far more at risk than, let's say, the servant or the nurse in the future. And it turns out that did actually not come to fruition until now. So my question to all of you, and yeah, I would start with Hermann on the left side. In your looking back in the last 10 years, what were for you the most surprising, let's say, benefits that turned out to be a dud? And what were the surprising ones that you did not expect to be a success?
Sure. Well, as many of you know, I've been in technology for a while, so I've seen these technologies come and go. Some come and stay, and some do come and go. And I've never seen anything like AI. And I'm going to make a big no-no for any speaker. Normally, they're allowed to make 3 points. I'm going to make 5 points, where AI is substantially different from anything that we've ever seen before. 1, we got 100 million users in 2 months. Nothing has ever been adopted as fast as that. 2, it's been trained on everything. All of mathematics, all of physics, all of chemistry, all of biology, all of history, all of geography. So anything that we've ever thought about as humans and left digital footprints of in our textbooks, in our whatever exists, these large language models have been trained on. There's never been a technology that's been trained on everything. Which leads me to the third point. It deals with anything. So it is also the most horizontal technology that we've ever produced. So after these 3 technical points, I now come to the remaining 2 points, which are actually probably the most important ones. And point number 4 is an economics point. If you look at the core of all our economic modeling, and Monica will tell us a lot more about that, at the core of any model is productivity. So the only known way of making us better off is not to increase the wages or to decrease the prices. It's increasing the productivity. That's the honest way in which we can make ourselves better off. Now, this has been known for a while, but politicians still have a great difficulty understanding that it's productivity that we're trying to improve in order to improve our lives. And then I come on to point number 5, which Stephen has already touched on, this point about technology sovereignty and how Europe works with this. I'm one of the signatories of a letter that has gone to the Commission on the proposed legislation on AI, which of course was legislation that was put before the European Parliament before we've had GPT-4 and ChatGPT. So if you believe my first 4 points, that productivity, that this is the first technology that we've ever produced that is actually can increase our productivity in the economy across the board. And the most beautiful example, of course, we heard from Mohe earlier on the GitHub Copilot, where you implied a productivity increase of for me 50% or so. Mm-hmm. I have lots of examples in our portfolio companies where the productivity increase has been 30%. The Copilot is probably one of the best productivity increases that we have. But if you look at the productivity increases in coding, since coding again has become a very horizontal activity, that in turn has a very horizontal effect. So if we legislate in Europe much more stringently than the people in the US and in China, and we deprive ourselves of the main engine that gives us the productivity increase in our economy. If you think this through, this might actually create a new type of technology colonialism, where we become much more dependent on the US and China, rather than becoming less dependent by being clever with our legislation. So these are my 5 points, rather than 3.
As long as it's a prime number, we're safe. Good, then let me hand over to finish the left-hand side. Steve, yeah, let's say, just as a reminder, what are, let's say, the biggest surprises in terms of positive impact, and where did you think it will be successful, but it didn't actually happen?
So I guess my surprises are mainly technical. We started with trying to create AI systems by trying to design the system ourselves and say how we would pre-process data to structure it, to feed it into a small model that would then produce something. But what we actually found is that you just feed the raw stuff in, throw lots of compute at it, and it produces better answers. So don't try and design these systems, let the data create the system. I wasn't expecting that, particularly, I mean, when we started with image models and you said, just give it the pixels, don't try and break things up into elements or do sort of pre-processing, just give it the pixels. So that's the first surprise, a technical one. The other surprise, I think, is that we're doing experiments. You know, here we've got something that is a mathematical, logical thing, and just as if it was a piece of physics apparatus in the lab, we're doing experiments, computing experiments on these large models. And I think it's quite surprising that we have to approach it that way. So yeah, a couple of technical surprises rather than societal surprises.
Okay, thanks a lot. I think we have microphones on this side. Yeah, let me continue.
Yeah, thank you. I'm gonna continue with the point you made, and maybe object a little bit to that point. So, well, as of economics, the question of employment effect of the eyes is kind of the most important one. There are a few more other which I think are interesting. I'll get to them, but let's stick with the employment. I don't think I fully agree with you. I think there will be jobs which will be fully replaced by AI, but the difference is the political discussion we have is about all those jobs which will be lost. We seldomly have the discussion about the jobs which will be created. There is a very simple reason for that. It's much easier to quantify the jobs which are lost rather than the ones which will be created, and it's much more difficult to understand, if you're not trained in economics, why other jobs are created. So myself and Florian have been teaching a seminar in Alpbach the couple of days about trade, and we also teach the students that trade destroys jobs because maybe they're moved to China, but the indirect effect, because people are more efficient and the prices are lower and we can, gain from trading with each other, create more jobs. And this is a similar case here. So we quantify the lost jobs. We have hard time understanding that the fact that we are more efficient and more productive lowers the prices, increases the demand, and then the companies which are more productive can employ people in other tasks. That said, I don't believe the horror scenarios. I don't believe the employment effects on average will be negative. I think they will be positive. However, we will have an issue with the skills, right? So AI is just another development of what we've been observing in economics about results of automation. So previously what we did is we had a lot of research about how industrial robots replace some jobs and then the other jobs are created. But these were like manual tasks. But we had this kind of observations before. So now we've gone to the point which will have similar effects. But they're obviously qualitatively different. So what is new in this research is we know that previous automation has more or less replaced routine manual jobs. The current developments rather start to replace jobs in higher level of skill. They start to replace creative jobs, those management jobs, marketing, so the things we have not had before. So this will for sure happen. And the other thing is that the people will lose jobs. So let me give me one example. You've mentioned DeepL yourself. I use it every day, right? So I would not get it corrected by an actual translator anymore. I mean, I trust the tool. If I translate with DeepL, I don't call my proofreader and say, like, can you check whether DeepL is right or not? No, this job is essentially gone for me. So there will be those effects. So I think we will have an issue with how to train people, not those who lose jobs, to train them into other jobs. We'll have an issue with inequality. We will have an issue with preparing our education system for this change. So we will have short-term frictions. Although I believe that in the long run we'll profit from that. And just one final point, because we focus a lot about employment effects, but I think the economics of AI is much more than employment effects. So let's give me, let them give you one example of a very interesting study I came across recently, which is about DeepL actually. So they look at the productivity effects of DeepL on the one hand, but they also say is that the fact that it's so much easier now to translate things has immensely boosted trade in services across border. Let's think about Tirol. There is this, small hut which wants to, get customers from abroad. They can use DeepL and they export the services much more easily than they had before. So we have trade services effect. And one last example maybe, because when we talk about economics, we talk a lot about prices and productivity. There are obviously productivity effects. You discussed those. I don't think I have to repeat that. But one other thing is the question of so-called consumer surplus. You had as one of your examples, you had the recommender. You didn't mention it, but you had it in your slides. So recommender is a classic case of, there is no price effect, there is no productivity effect, but eventually it improves the experience of the customer if you have a recommendation. And we economists measure this kind of difference between what you're willing to pay for a service and how satisfied you are with the service, with the so-called consumer surplus. So obviously we also have those effects. So just to give you 3-4 examples beyond the employment and the productivity, which is a fascinating area, and we have a conference on that in November with Clemens, right, in Vienna.
Which day?
And the 24th.
Exactly,
yes.
That's what I want to hear. Thank you. Yeah, last but not least, Uwe.
So I'm last, and so most things have already been said. I was hugely surprised by how successful pure neural nets were. I had talked to the OpenAI founders before, and I thought that they were purists, almost in the extreme, that they went, skill will do it. They didn't believe it, but it turned out to be actually true. As you said, it is true because they used almost all public data that is available, and that has gone into these systems. So that also makes me wonder about what's going to happen now. Because in my particular field, using AI for coding, all public source code has been ingested. And so we cannot make a model that is twice as good by putting in 10 times as much data because we don't have even twice as much data. And so some quite big fundamental advances will have to be made. We will see advances through reinforcement learning, and there the incumbents will have a huge advantage because they have the usage data. I find it very difficult to understand why all these people started playing with ChatGPT, freely giving their data to an American company to make their product better. I mean, that was the reason that ChatGPT came out. Let's just be clear about it. So I think that as Europe, as European scientists, as European entrepreneurs, we have to act very fast and start, in particular, creating open source models where we are completely clear about what data went into it, how it was pre-processed, and share the usage data so that we do create a playing field where we can make sure everyone benefits by this huge technical advance. And I agree with Herman here that it's probably the biggest thing that certainly that we've seen in our lifetime, and it's dangerous if we let it only be developed elsewhere away from our continent.
Great. You brought up so many points. Now it's the time to toss out my prepared notes out of the window because you mentioned everything already. But let me directly pick up on what you just said with the open source movement and the technical sovereignty, which leads me later to Herman, because in my opinion, this is the largest change in the last 12 months. So I remember The Economist in June of last year had a long article on so-called foundation models. This means basically the stuff OpenAI did back then, like DALL-E 2 for image generation and GPT whatever. I think it was 3 back then, so long before ChatGPT. And they made the case that they foresee a future where you have a couple of very large tech companies. And in the same way as you need to access cloud infrastructure from the hyperscalers, you will need to access these foundation models and throw in money to use their API. And this basically got invalidated 2 months later, first with Stable Diffusion, and as Steve has shown in your talk with Llama 2 and what happened afterwards. But in the opinion of the panelists, what is really necessary, let's say, to take this momentum that is happening at the moment, not just bring this to the startups, but also, let's say, bring it to the policymakers and create an environment where we are not so much, I would say, reliant that a company like Meta is donating their models and you can use it as long as you have below 700 million active users per month, but that actually something like this gets created in Europe. So maybe a difficult one, who wants to go first?
Well, since I'm writing a book on it, I hope I have something to say on it. The book is on technology sovereignty and this danger that there's going to be a new colonialism, this time based on technology rather than military might. But make no mistake, the dependencies, the potential dependencies that are being created in technology are no less severe than military occupation in the past. So this analogy of a colonialism is not that far-fetched. I originally thought there were going to be, through technology sovereignty circles, the US, China, and Europe. And being a passionate European, I said, well, if you're a third country and you have to think about which of the three you're going to join, I recommend you join Europe because it's the only one that doesn't want to be a hegemon. Because the Americans will ask, are you with us, are you against us? If you say, well, we're going to be with you, they say, well, it's wonderful, now do exactly what I say. Chinese are no better with their Belt and Road Initiative. And Europe is the only area in the world that has shown that, we always bitch about Brussels and its bureaucracy, but it's the only area that has a governance layer above the nation state which sort of works. And it has a proven track record of accepting national differences, Brexit notwithstanding. So I hope that Europe would be the shining example to propose to everybody, and I still partially feel that. But I very soon came to the conclusion, because I know a little bit about the semiconductor industry, that sovereignty in the sense of doing everything ourselves is just completely out of the question. You cannot do it if you're Europe, you cannot do it if you're the US, and you cannot do it if you're China. And a sort of example of how true this is when I realized that before a chip goes down on the circuit board to produce an iPhone, that chip actually traverses 40 country borders. So this hyperconnectivity that we already have makes it absolutely impossible for a single country, even of the size of the US or Europe or China, to be sovereign in the sense of being autark, of being completely self-sufficient. So what is the best thing that we can do in order to avoid the dangers of dependency? Well, I think the right strategy, and it's difficult to convince politicians of it because they're so amazingly ignorant about how the economy actually works, especially in very technical areas. The thing that you have to do is to make sure that you always have choice. You always have multiple choices. Mm-hmm. So there are really three questions you've got to ask yourself. Do we have it ourselves, in which case it's fine? If we don't have the critical technology, do I have it from multiple independent countries so that no single country can hold me to ransom by withholding it, as the US, for example, has done with EDA design tools. They have a 90% market share with Synopsys and Cadence to design chips, and Trump has used this on ARM, for example. And if you don't have multiple countries, independent countries that you can get the technology from, you then have to ask the third question: do I have unfettered, long-term, longer than 5 years, guaranteed access from a single country, typically the US or China? And if I get 3 no's, it's one of those things where you have to do whatever it takes. Because if we don't do it, then we create that dependency on a single country that can be as serious as military occupation in the past. So that's really the conclusion that I've come to.
Thank you very much. This is I think I was reminded a lot of the book Chip War. Did you read that one?
I did, and it's an excellent.
It was the business book of the year last year.
Yes,
in the FT.
And sometimes it's even accurate.
Great. So while you're waiting for Herman's book, Chip War is the way to go, at least on that one. So let's say staying on the political side, but when it now comes to setting up funding programs or policy. Let me ask the question directly. Do you think something like the European Semiconductor or Chips Act would make sense in the AI space, or do you think this is too bloated, the 30 to 35 billion euro that get invested, or would other policy recommendations make more sense to achieve this level of sovereignty that Herman was describing just now?
Let me start maybe with the first point, because also an economic one, about what you said, and you said eventually that we're in a situation when few large players kind of overwhelm the market, and this is the classical case of what we call in economics increasing returns to scale, because the reinforced learning means that if we have more data, we can learn more and more quicker than the others. And once this advantage starts to grow, it starts to grow exponentially, not only in technological sense, but also in economic sense. So although I'm one of the people who are always very careful about saying, okay, those guys are monopolies and we have to destroy them, because we have seen monopolies in the past which killed themselves on their own because some new better technology picked up, like MySpace, the famous case, right? But in this case, when kind of on the brink of saying this might be the one case in which we might really need to intervene in economic sense, and one idea there is, at least I know of, is by Victor Meyer-Schönberger, who works in Oxford at the Internet Institute, so is very keen on a data tax. So the tax on data, in a sense of we don't need to raise money from that, that's not the point, but the point is to kind of get rid of this comparative advantage with a tax. And I just joined into the room, that might be one of the things we can do. The point is, the problem is obviously with this task is the same problem with the task, for instance, on emissions, is that we need to be employed internationally, because we deal with the players who are generally active internationally, and we all know where it works with environmental taxes. But that's just to make an economic point on the discussion of this advantages that the big players have. Regarding the European strategy, I kind of rather side probably with Herman on this point, is that probably it might be even too late to start to try to pick up, build things on our own. We can, fit in niches, but it's probably the best way to diversify our sources and try to cooperate. So it's the same about gas imports, it's the same about technology imports. So diversification is the key. And the one thing Europe can really do is to try to fit into the niches which has not been taken, and try to find cooperation partners in which we know we have those stable relations Herman was talking about. And, I was listening to you about, 5 years contracts. Is it really a secure way? We teach the seminar now, one of the topics we teach is the weaponization of trade, right? So what Putin has been doing to Eastern Europe for 20 years. Well, they had contracts, right? And then they just closed the valve anyway. So probably diversification is the best thing you can do, and probably minimizing risks.
So to have a provocative, perhaps, follow-up question, do you think that this type of diversification at this scale is even possible without the defense policy? Because
probably not. I'm not a technology person, disclaimer, but what I know about developing many technologies which are relevant, including Internet, AI, they all obviously are very much connected, and probably this would make sense to have a European defense policy also for the technological spillover.
Because this is something that is mentioned in the book Chip War a couple of times, that, let's say, because of the importance semiconductors have in weapon systems, that's one of the major reasons, or let's say one of the key factors why things are playing out like they do between the United States and China. But if Kissinger, I think, also published a book last year on AI, and he's making sort of the same case for AI technology, saying you will have the same, let's say, import-export restrictions. We already see this now with the H100 from NVIDIA, and the H800 was specifically created for China, and that you have this on an algorithmic level. That would be actually a question to the two British gentlemen, because I think one of the reasons that was very often cited by the Brexiteers was they feel that, let's say, the unfair advantage or unfair competitive advantage regulations from the EU are like a straitjacket around really creating national champions in semiconductors or in AI. Is this something that you see now getting more steam, or was this just an empty promise number 2001 that did not come?
So, Brexit is, I think that was quite nicely put, a disaster that keeps on disastering. I hate it to its core. I don't think when you look at what the UK is doing now, it's really creating anything better. There's talk of them spending 100 million creating a computer system for training large models. That seems first of all, it's not anywhere near enough money, and secondly, it's government trying to do things rather than government enabling society and companies to do things. And I fear that Europe might do the same thing. If it was me, I'd just give a pile of money to Aleph Alpha, to be honest, and other similar players. That's the way that people who are already doing the right things, help them grow. Aleph Alpha has got less than 1% of the funding of OpenAI, but there's no reason why they couldn't do the same things. And open source is great, but at the moment there's too many different tribes trying to create their own language models or sources of data. Somehow they need to be brought together so that we've got one attempt at creating a solid open source solution that has enough scale to really take on the big American players.
So basically something like a targeted open source movement like Linux, and the Linux Foundation was later on, and not
Yes.
just the general GNU, which can be everything and nothing at the same time.
Yeah.
Good. I think you wanted to add
I
something.
I fully agree with you. So I forgot to answer your question actually before. So you were asking about the funding, and I want to make a bigger picture. So you asked about 45 million. So what we have now, the new movement across the world, is the new industrial policy. So the Americans started with the IRA, and now Europe is also doing this in environmental topics mostly, but also in some other topics. And I think this is completely wrong, because I think it relies on a misunderstanding how innovation processes function. So they function like evolution. I guess those politicians also do not understand how evolution works. Evolution is not a guided process which from the beginning knows where it wants to go. Quite the opposite. It's a random process where out of a big number of many possible mutations, one of them will be successful. And it's also how innovation works. So you have to have a critical mass of things, and some of those things will be successful. And this is what we should be doing in Europe instead of targeted industrial policy. Which brings me to the funding point, is that this is precisely the kind of institutions we need that allow for this process to take place. Americans have them, and they have great institutions of this kind. They have venture capital, and they have capital markets which finance ideas, and some of the ideas will be bad, some of it will be good, but there is enough money so that the critical mass is there. And this is what we should be doing, and I hope Herman agrees with me, is that it should work in a way that there should be public money for sure, but this public money should be placed into the hands of people who know how to, create winners in innovation. This will not be bureaucrats from Brussels. And we have research on that. I've written 2 papers on that, in which we compare the data on venture capital investments from public sources and private sources, and the so-called indirect public, which, for instance, European Innovation Council does. And we find that the direct public financing tends to work very badly. Private one is good, and kind of the indirect public is very good, because it's not only keeps the decisions into the hand of people who actually know what they're doing, but also gives them financial leverage. So there is a combination of the benefits. And that's what I think we should be doing in Europe, instead of targeted industrial policy in a similar way we try to do with the climate subsidies.
Thank you very much, Monica, because when I chaired the advisory board for the European Innovation Council, that's exactly what I insisted on. I argued that we should only allow Brussels to put money into organizations where at least 50% of the money comes from the market, and that has worked extremely well. So for every euro that we now spend with the EIC, which is a 10 billion euro deep tech venture fund, it's by far the largest venture fund in the world. But it can only, for every euro that we now spend, we get 3 euros from the market, so it's actually not 10 billion, it's more like 30 billion. Having said that, I still think we need another 100 billion for a technology sovereignty fund in Europe on the same principles.
Thank you very much. I mean, whenever I look at you, I have to think of Japan, because you mentioned Norwegian wood before, and I lived for 7 years in Japan. Because I remember Japan always used to be the laggard, both in adopting deep tech and when it came to the creation of startups in general. They were like far behind almost any other developed country, or far behind the G20 nations. And what Herman and Monica just described, actually during COVID, Japan radically changed its policies. They actually now demand the pension funds that they spend like 3.5% of their volume, put it into venture capital, and now together with, let's say, special immigration rules for, let's say, talent visa that you have in Canada, for example, startup activity in Japan is now going through the roof. And this is really comparatively small, tiny switches that the government had to flip. Yeah, and as Herman said, this is what the EU is doing at the moment. This would be money-wise on a Japan level. They need to scale this by 1 order of magnitude.
That sounds a good idea. Herman mentioned the regulation that is currently being put on AI in Europe. I do think that if we wanted to encourage technological sovereignty, we especially must make it easier for open source development of AI systems. At the moment, they are in the drafts. They are being put on similar restrictions as large corporations, and that would make it even more expensive. Almost impossible for open source developers to do the same thing. I do think that, I would like to say that once again, that it's extremely important that this technology is open source. We must know what went into these systems, into these models when we use them. People worry about infringing copyright, infringing licenses. We cannot know that for sure if we didn't know what was in the training set. We can't see. I mean, it's possible that a model just came up with exactly the same text as a human being. It's a small chance, but it's possible. We can only tell for sure if we can also see what went in the model. If we talk about problems with bias in the output of the model, we can only tell whether that is truly there if we can look at what went in the model, into the model and at the start. And so we should demand as society and as technologists and entrepreneurs that we actually get told what went into these extremely important components that we build, that we're building on.
Yeah, thank you. This is actually, again, staying in Asia. Very interesting, because what the Chinese government put forward in the types of regulation for generative models is far closer to the reality you just described, because it's made by technocrats, than, let's say, the bureaucratic view originally developed in the European Union. And this is now also the biggest sticky point around open source. Let's say, who is at the end of the day liable, or who owns the liability if something goes wrong? Is it already happening on the open source level, if you publish it to GitHub, of course, or is it actually in the application? And this is where the process is now stuck in the trilogue between the EC, the Parliament, and the national governments. Great, but let's say we spend a lot of time. Actually, we started with AI. Now we're on the very macroeconomic view. This is actually your home turf. But now diving a little bit into the AI applications, I think both you and Steve had this insight. There was a study by Google released a couple of months ago. It was on the AI adoption in retail, in the largest retailers. It's like, let's say, Tesco, Carrefour, Walmart, the real big ones. And the sort of surprising takeaway was that in the opinion of Google, only 5% of the AI projects that are started are actually so-called high-value use cases. What does that mean? That it gives a measurable impact on your profits, which is insofar interesting if you think how the whole AI hype started and so on. Recommendation algorithms or adaptive pricing was always given as a prime example where you can, let's say, immediately create more profit. But somehow, if you look at the large corporations, there seems to be a very big reluctance to actually go that route. They very often go for the safe bet, to, let's say, auxiliary processes and so on. What is, in your opinion, the reason for this behavior? And follow on, do you see this changing now with the, let's say, abundance of open source technology available?
I think that's rather a hard question, isn't it? So, I think if you're looking to do one thing that completely changes a business, that's very hard and very unlikely to work in every case. But if you make lots of small changes, you introduce AI here, AI there, AI in other places, it will accumulate. And so I think that's what retailers ought to be doing. It's what everybody ought to be doing. Not trying to find this huge, great thing that you can apply, but just using the process of progressive scale and improvement to make AI work?
I think there is an analogy with the computer paradox. When we introduced computers, for about 30 years or so, there wasn't really any significant increase in the productivity, and everybody thought, well, these computers are really no good. Why are we using them? And then you might know the study. Amazingly, once the infrastructure was in place, it finally then produced the productivity increases that everybody expected. My expectation is that this will take a much shorter time in AI. I think the translation from the adoption of certain AI practices in big companies and the resulting productivity increases will be much faster.
I agree with you, and it kind of goes back to the discussion about replacing job and whether the AI will need human supervision or not, and what kind of job. So the two cases you name are obviously very, very critical because it's about human life, and then we'll have a much longer time before we trust the technology more enough. There is a lot of status quo bias. I believe eventually it will be replaced completely. It's just we'll probably force it to be much, much better than a human before it starts. So we will not ask it to be as good as a human. Human make mistakes, doctor make mistakes, but we'll ask it to be much, much better. We actually trust it. In some less maybe critical technologies, we will say, okay, if there is a grammatical mistake in my letter, translated by DeepL, nobody dies, so the levels are different. But the status quo bias, the people are generally very skeptical of technology in Europe in general. I mean, in Austria, maybe not in all places in Europe. So they will be very skeptical, and this will slow down the process. But eventually, I'm quite sure that once we have those standards, the technology, the productivity will pick up quicker. The productivity effect.
If I could just add one point on the regulation. I think there are two things that are very important. One is the open source initiative. I think this danger of getting monopolies, American monopolies again, can be partially offset if they're generous enough, as Meta is at the moment, to make it open source. So we've got to avail ourselves of that, very fast and see if we can make the best of it. But the other point about regulation is, I think it's the regulation has to be a global regulation this time, because if there are significant regulatory differences between Europe and the US and China, that gives one of the three a clear advantage, then that's no good. There will be either everybody will move to the US or Britain because they don't regulate, or it will create lots and lots of tension. So I'm very pleased to see that all the regulators in the world are trying to work together to come up. Well, first of all, they all agree that AI does need to be regulated. But that this regulation needs to be harmonized across all the big nations.
That it's not the race to the bottom.
That's not the race to the bottom, yeah.
Yeah, I think, what's the name of the British Prime Minister? I think he has planned a summit for, actually they want to take a leading role in that. Let's see if that works out. But I think this is the most promising movement, or let's say initiative that I see, that you actually bring heads of state together, or let's say the ministers in charge. Great. As far as effects are concerned, we talked about productivity gains and so on. There's this, let's say, very famous image that that's sort of shared once a month on Twitter, or X, like it's called now, where you see a Boeing 747, and then there's always, let's say, a tagline, something, back then this took 16 months to develop, and then you see a very simple tool on the right-hand side, like a toilet, and they say, look, nowadays this takes 5 years to get the certification to install a new toilet in I don't know, in a train. How do you see this trade-off between, let's say, increased product safety and quality versus actually creating abundance or new features? Where would you put AI on that scale?
So I think you've got to adopt a different approach according to what the AI is being used for. Clearly, for ChatGPT being used for people to overcome writer's block or just create text for themselves, it doesn't really need to be so heavily regulated. On the other hand, medical applications, it's a more serious question. The difficulty, I think, with these models is that there aren't going to be very many of them. And that's why the information needs to be open source. If you had just one person, you don't need to know every piece of training data that's gone into them, because there's loads of other people, and as a society, you get an averaging effect. But if you've only got one model, then I think you need to really know exactly what's going into it, because it's going to be used for so many things.
Yeah, and it also creates later on the risk that, because you mentioned GPT and writer's block, that now the data that is put on the internet nowadays is created with GPT. So you basically, training data in the future is the output of old models we're using nowadays. Good. Maybe when it comes to productivity gains, you showed some very interesting bar charts and so on. What would be interesting to know is how, let's say, was this far beyond your expectations, or was this basically the target you set out when you started to develop?
So we definitely didn't set out that target. When we started, the models were not nearly good enough. And in fact, most of us didn't believe that they would get as good as they did. Once we did the study, we had a good idea that it was that the numbers would come out like that, simply because we got so much feedback from our internal users and later also outside GitHub.
Did you also conduct studies, let's say, based on the, let's say, percentile of the skill level of the developers, how they are affected and in which way they are affected?
Yes, so in fact I had hoped that it would show huge productivity improvement for the people who do not have a very high skill level. Personally, I think that the big promise of the technology is that people with no education in computer science who did not go to a coding bootcamp can still write their own code. That didn't come out in the data, and I think that the problem currently is that if you use this tool, you still have to be able to judge the output and say, yes, that's what I wanted, tab. It's like knowing, you have to know the programming language just well enough to look at it and see whether this is plausible or totally off the wall. So I think that we'll probably get there for less skilled users, but that we're not there yet.
Okay. And
It's really interesting. I forgot to mention this one study before, because there is a study from some guys from the MIT a few months back, which did pretty much exactly the same what you did, but with ChatGPT. And they found pretty much exactly what you did. So what they found is there was a huge productivity boost in writing. It was a huge increase in self-satisfaction and satisfaction with their job, so they also measured those sort of things. And they also found that it had a larger effect on people with lower levels of skill in the first place, which brings me back a little bit to the first point I was making. So on the one hand, we are afraid a little bit of the inequality development of AI and automation, because what we have seen in the past is that past waves of automation have increased inequality, because a fairly low share of people with high skill profited from in productivity boost, whereas some larger groups of the society have not benefited because their jobs were automated or replaced and their wages did not increase. So here we might have a kind of a counterexample. So the qualitative change might be in this case that the inequality effect would be actually lowering, because people with less skill will be boosted more than people with more skill, but that's very open. So those studies are like few months old. We really don't have a clear picture yet.
So talking about my own skill level, I definitely can write programs with Copilot that I wouldn't have written without, just because I don't know the language or the APIs well enough.
yeah, I think with regard to the timing and before, I guessed it correct. Good prediction model. Before we go to the Q&A session, some sort of closing statements. I mean, I think there is this quote that is often attributed to Bill Gates. I'm not entirely sure if it's really from Bill Gates, that is saying that people often overestimate, let's say, the technical leaps that could happen in 2 years. and completely underestimate what happens in 10 years. And as I mentioned, let's say, or it was mentioned a couple of times today, that large language models are really for many people like a black swan event that come out of nowhere, especially in terms of user adoption. What would you expect to happen in the next 2 or 3 years as the next big surprising application? Maybe you would like to start, Uwe, because you mentioned, for example, reinforcement learning before, or that this is like one necessary next step. Where do you think the next big wave will come from?
So I think it's going to be in teaching tools, teaching all sorts of things. I mean, teaching programming, obviously, but also teaching foreign languages and many other topics. Because good teaching is a matter of a dialogue with the student, and so rather than the student having to passively consume the knowledge in the textbook, you can actually the system can adapt to the student's knowledge, to the mistakes they made in the past, and train you in exactly the things that you wish to learn. So I think that in educational applications are the biggest, is where I expect the biggest advances.
I have no idea. I have no idea.
That-
Like, it's an honest answer. I told you, it's much easier to quantify the things which are already here and get lost rather than to figure out what the next big thing is. I'm not an interpreter. I'm lucky enough, I don't have to know this, but I'll be happy to quantify it when it's here.
Yeah, see, you also seems you also don't like playing darts with closed eyes. Not because it's very famous that, how to say, there's even, I think, the Wikipedia entry for inventions where the inventors got the actual application completely wrong. It's like Alexander Graham Bell thought the phone would be used to broadcast, sermons from the church, for example, and so on. This is a very long list to fill. What about you, Herman?
Building models. So I think the core problem in our society at the moment is rhetoric can win over the scientific method. Brexit is a super example where we've had economists work very hard to build a very complex model of the British economy and look at what Brexit would do to Britain. And all the models roughly came up with the same prediction that it will harm the British economy to the tune of 4% over, I think, a 10-year period. And then there was a guy, who turned out to be a compulsive liar called Boris Johnson, who said, take back control. And that one sentence, take back control, won over hundreds of man-years of careful work that created a very high quality, not one, but lots of high-quality models from different banks, from the Bank of England, from various commercial banks, that produced correct predictions. So I think the right way to make predictions, make decisions for politics or for anything else, is to inform yourself of high-quality models that have predictive power. And I think, in my opinion, the most significant contribution that AI can give us is to provide us with these high-quality models faster and make them accessible to us faster than in the past. One particular data point here is a thing that about 15 years I called the evidence engine. And William Tunstall Pedow, who I backed in a company called Evie in Cambridge, which was bought by Amazon and became Alexa, so he's the father of Alexa, has a new Cambridge startup called Unlikely AI, which does exactly the opposite of what GPT-4 is doing. It's completely reasoning-based. It is not statistically based, but reasoning-based, but it's all also language-based. And he asked me what I called this thing that there was a talk about what next, and I, had this vision of an evidence engine. And the evidence engine is a sort of a ticker tape at the bottom of a TV screen that gives running commentary on what a politician or anybody else is saying, of providing a number between 0 and 1. If it's close to 1, there is a lot of evidence out there supporting what the person said, and therefore it's green. If it's close to zero, there's a lot of evidence contradicting what the person's just saying, and therefore it's red. If it finds no evidence for or against, then it's in the middle and it's brown because it's unadulterated bullshit. So I said, William, why do you want to know what I called this thing? And he said, I think I can build one next year. And then I asked the head of AI for King, completely independently, and said, when do you think you could build one of these? And he says, next year. So, there is the chance of having real-time fact-checking, which might actually change our democratic process.
And the panel.
You've got some evidence. From 2 sources.
At least 2, yes.
So
the panel next year also more difficult.
Yes, I might not turn out.
Only yes and no.
So I think something very interesting can happen when you combine these large language models with tools. You give them the ability to create actions in the real world, and you give them the ability to use tools that will do things that they aren't good at themselves. An AI seems to be a bit like a person when it comes to doing mental maths. But give it a calculator and it can get the answers right. So this business of adding tools to AI, I think, is interesting. And I agree about education being the first big application.
Thanks for the words. And the best way of learning is to ask questions. So now let's start with the Q&A session. If you have any questions, what was on page 3 of Steve's presentation, or how does code line 27 of UCHE actually works, now is the time to ask. So we have microphones here. You just raise the hand and the microphone will be delivered.
Sorry, right at the back. Needs to be faster.
Thank you. Hi, Andy Collins, University of Bristol. So very interesting talks. The entire panel was talking about the large level of data that went into it. And Steve, you mentioned about the human bias checking that was going into it. My question is around, where do you see in the next few years how bias could be controlled and how things influenced it? An evidence engine would have been great 7 years ago. I would have been full on board with that. But something like that's transformative to society. If you've got bias that's trained by humans, how can you ensure going forward those kind of safety aspects? Where do you see that? And if it's being trained, if you've got this bias data and everything that humans are writing now, if everything's already gone in, will stuff that's already been produced by AI start going back into the model and degrade it or improve it? I don't know. Thanks. Sorry.
So I think it might well be with code that everything that's been published is now being ingested. That isn't true of text, and it also isn't true of other sources of data. Video, for instance, gives you a whole new rich source of information, not just words, but kind of multimodal information. How do you remove bias? I think I'd better say I don't have a good answer to that.
So I've got quite a strong opinion on this. I think that all the questions about AI safety should be questions that should be asked of the application that uses the model. We're talking here about these large language models, the foundation models that could be the basis of many different applications. It completely depends on the context, whether the level of bias is acceptable or whether the level of hallucination is acceptable. And so the onus is on the people who built an application on top of these models to put in the necessary safeguards. It's wrong to try and make rules for what the component somewhere deep down in the system may or may not spout out. It is you as the application builder who has to make sure that the nonsense doesn't make it to the end user. And often that will require having another model that looks at the output of the first model and tells you whether it's somehow offensive or whether it violates a license restriction or whatever.
Hi, Lalit from Medical University of Vienna. I like the point that everyone actually talks about open source LLMs. And I also like the analogy that Clemens brought in while saying that we need something like Linux where everyone actually cooperates and does something. But Linux was actually formed in a different way where there was no compute needed. It was like blood, sweat, and tears. And everyone just said, screw Microsoft, we need to do something nice. I'm just saying what they thought. But in our case, with large language models, even collecting the data is not the hardest part because there are multiple pots of data that are being collected. I think the most complex part right now, or the expensive part, is the compute. I mean, in our case, if they want to have an open source model, like let's assume in Europe, yeah, most of the open source model around the world are generated by companies. So if you take Orca, again, Microsoft, if you take Llama, Facebook or Meta, and the most promising one, Vicuna, is from Stanford, but it's Stanford. So when it comes to European perspective, are there any initiatives that Europe should actually promote in order to just satisfy the compute need? Because we do host, I mean, I say we because I have half of my life training in Europe with education. There are 7 supercomputers around Europe. Is there a way to form like a coalition just to train an open source model, which is X% of GPT-4 or something? I'm happy with that one.
So first of all, I don't agree that getting the data together is an easy task. I do think that we do need people coming together and all working on the same data sets, or at least putting it together in the same format. I also don't quite agree that these models are always expensive. So as I said, what we're building on is something similar to OpenAI. What we built on Copilot on is something similar to OpenAI Codex. At Salesforce, a very small team, in fact, one person with a couple of helpers, created a model called CodeGen. And it's not quite as good as Codex, but it's within a few percentage points. And he did it certainly not with billions of dollars. I mean, Salesforce invests some in this area, but nothing in that to that extent. And so I think we can make a lot of progress being more thrifty. We don't need always doing it the second time is also easier, right? I mean, OpenAI needed a lot of money because they needed to put lots of experiments for the first phase, but we can now do it better. It would be great if we could have a European-wide facility to do this sort of thing. I mean, we do it for expensive physics experiments. So why not also for expensive AI experiments?
Yeah, maybe touching upon this one, it's quite interesting because the European Union is always, let's say, realizing the strategy via public-private partnerships. The PPPs that, let's say, then allocate billions in type of horizon programs. And the one for AI is called ADRA. It's the AI Data and Robotics Association. It has over 7 years a budget of mind-blowing 2.6 billion euros, which is like, I don't know, what Salesforce is perhaps spending in 1 quarter on R&D in general. And what was interesting in the interaction with the European Commission was that you need a different type of processors. Actually, this was very nice in the slide that you showed, where the IPU was on the right-hand side, the CPU was on the left side, but in the middle you have the GPUs. And from our exchange with the Commission, this was not something on their radar. They thought they have, let's say, high-performance computing, check mark, mission accomplished, and now use the HPC to train the LLMs, for example. So this sort of came out of the blue, and they're now scrambling together on the one hand side, on the hardware side, what you mentioned in the question, to come up with perhaps either it's a CERN for AI or it's a federated system, but actually do something with GPUs, to put it simple like that. At the same time, you have a grassroots movement that started, I think, in Germany. It's called LIAM. I always forget how to pronounce it. It's you usually know that large language European model.
I know of it. I don't know how to pronounce it either. My German's awful, unfortunately. I need to work hard on that.
Yeah, so this might get some steam. Where I see a little bit of the risk is that, let's say, a fallback into the time where Europe wants to create national champions. You know, the French now have Mistral AI. This is like their shiny new thing. The Germans have Aleph Alpha and maybe Liam in the future. So I think this is a little bit of a hindrance to actually get the European approach or agreement, as you already have for GPU clusters.
Yeah, so there is an example of a large language model being trained on a supercomputer. There's a model called Bloom, which is about the same size as GPT-3, that was trained on the Jean-Zay supercomputer in Paris. Unfortunately, the methodology of that wasn't great. The data wasn't good. The model didn't perform terribly well. So I think that perhaps says the data is really quite a critical part of this. I'm suspicious when you have kind of publicly organized, publicly managed computer systems. I'd rather see privately managed computer systems that you get use of, but that's perhaps just my kind of economic bias.
Yeah. Now, I'm quite excited about Mistral, for example, because what you really want is very high quality people that understand what they're doing, and that Mistral group is a world-class group. And we just have to put enough money behind them, private money. One of the biggest problems in Europe that we have is actually not startups. Europe produces more startups than the US. It's a little known fact. So we don't have a startup problem, we've got a scale-up problem. So we start the companies, but when they need 50 to, say, 300 million, which is that center gap, where Americans, when they see that the thing works, then put a lot of money behind them to make them global champions. I think Monica has already mentioned that the US has 4 times as much venture capital as Europe has. We're catching up. I mean, the good news is that European venture capital, for the first time in history, gives better returns than American venture capital, so there is money flowing into Europe, but we still have a factor of 4 disadvantage. But I agree with you. I think these private initiatives with outstanding people, because we still have universities that are just as good as the US, so we've got the people, we just need to put enough money behind them to catch up.
Should I answer?
Yeah, of course.
I just fully agree with Herman. The problem is still that although venture capital is great for some applications, it's also not the only the sole tool for deep technology, because venture capitalists have, 10 years period of investment, and in 10 years you usually are not even able to develop the things as way you want to. So you need the public hand. That's why I agree with you. So you need essentially both. So if you really want to have a deep technology funding, it needs to be a combination of both strong capital markets and this kind of indirect public financing, which we talked about, to get Europe really in the ranks.
Yeah, there's a question behind.
Thank you. Hello. Maybe a more fundamental question from my side, as I'm not that much into that topic. Herman, I think you mentioned it in the second point of your first statement, that AI is the only thing that is trained on everything that we have, everything that we know. So my question, as I understand it, it's trained on the only digital stuff that we have, or may that be? And the question then, is there some discrimination about the analog world, or do you see that, or does that have to be dealt in some way?
Well, that's an interesting point, but Stephen has already said there are lots of digital bits of information out there that are not in it either, and most of the video, is not incorporated, I believe, in the model, and I'm sure there are other digital things that haven't quite made it in yet, but most of the text that exists in digital form, I think, has been incorporated. The interesting, if you look at the way our brain works, and we actually think a lot in spatial terms as well. It's one of our great skills as humans. You know, we know that if something is there and something is there and you run that way, you know, how do you avoid the branch or whatever? So all that wealth of information that comes from pictures and 3D things, you know, that hasn't quite made it into large language models. Having said that, one of my surprises that I should have mentioned in the first question is the thing that has become very clear through the power of large language models is that language is actually, a natural language is actually a very good representation of everything that we know. So the power of language, and the reason why, you know, William, with Unlikely AI, that is doing only reason-based arguments, invented a computer language called UL, a universal language. But that universal language is very close to a natural language. And the building blocks in the universal language, not surprisingly, are words, sentences, paragraphs, and whole books. So, you know, we have this hierarchical ability of, you know, referring to an entire book as something that we can think about. You know, if you say War and Peace, everybody has a particular sort of view of Russia and Dostoevsky and so on. So, language is much more powerful than we expected.
And also you can take the same language model backbone and fairly easily teach it to use image tokens and reason about image tokens using the skills that it's learnt by reasoning about language. So it's quite easy to take a large language model and get it to be able to ingest pictures, and you can ask questions about the picture.
I mean, one of the great surprises that is described very well by Sebastian Bubeck of Microsoft, who wrote the famous, very controversial article that has seen sparkling of AGI, or the beginnings of artificial general intelligence. And he tells the story of the unicorn. He just connected the large language model to a drawing package and said, draw me a unicorn. But the language model has never seen a unicorn, has no idea of what dimensions are, and it started drawing a unicorn, which was really a very poor unicorn. But one of the things that he said has happened with the increase in the parameter space is emergence, that lots of things have emerged that these large language models can do all of a sudden that they couldn't do before. And the latest unicorns that it draws, never having drawn a unicorn before, just from the stories that it's heard about unicorns, are, you know, very reasonable unicorns.
Great. Yeah, the unicorns is a nice end note, especially to a startup program. So to the participants, you heard it, unicorns is the way to go. Yeah, with regard to the time, unfortunately, we have to close the session. As always, we are way beyond the limits. Thanks a lot for joining, and the gentlemen are still around. I say the gentlemen because Monica unfortunately has to leave for interview with the Zeitenbild 2, the main broadcaster. Yeah, you're excused. But the others are still, grab them if you have any questions. Thanks a lot for joining, and see hopefully many of you next year again. Thank you.
Well,